Hello everyone. Hello everyone. Am I audible? Can you please drop in a comment box? Am I audible? Okay, fine. Thank you, Karthik. We will wait for 5 more minutes and we can start that practice session. We can start the class at 7:05. Yeah. Good evening, all of you. Myself, Harish Karnati. I'm the Prime Minister Research Fellow at IIT Roorkee, PhD scholar. Today, I'm going to discuss Assignment 3, previous year Assignment 3 practice session. I hope the first question is visible. I'm reading that first question. Determine the value of V naught in the given circuit using the superposition theorem. What is the superposition theorem? Superposition theorem stands for the response across any element is equal to the individual responses when the each source acting alone. It means this source is having two sources, right? The 10 volt so only for superposition theorem we have to consider only depend independent sources only, that is 10-volt source and 2 ampere source. The response here, the response is V naught. The response is at the response at across this 4 ohm resistor is same as when 10 volts is acting alone, that is, let us suppose V naught at 10 volts and 2 amperes. The total response is both. This is the superposition theorem. The total response across the any element is algebraic sum of the responses when each source is acting alone. Okay. Consider 10 volt source is acting first. Just a minute. When 10 volt source acting first means, sorry, yeah, the same circuit, just I copied, that's it. When the 10 volt source is acting means the 2 ampere source has to replace with the 2 ampere source has to replace with its internal resistance. Actually, the ideal, sorry, the ideal current source internal resistance, ideal current source internal resistance is, one can comment that what is the ideal current source internal resistance. And what is the value of ideal voltage source internal resistance? Okay, fine. Ideal current source internal resistance is infinite ohm. Ideal current source, we have to make it as a we have to make the current source is zero. The current zero means, the current zero means open circuit, right? The open circuit means the resistance is infinite. Similarly, if you want to make a voltage source zero means, the voltage zero means it should be short circuit, right? Short circuit. The resistance of the short circuit is 0. Therefore, the the value of internal resistances of ideal current source is infinite ohm, and internal resistance of ideal voltage source is 0 ohm. In this circuit, first we are considering, I'm erasing this thing. Yeah. In this circuit, first we are considering the 10 volt source and making this 2 amp source 0. We are making 2 amp source 0 means we have to replace with internal resistance of this 2 ampere source. That is, we have to open circuit this thing, the 2 ampere source. That is, yeah, just redrawing. Yeah, this is 2 ohm, 10 ohms. I consider this is as a V1 for 10 volt source. 4 ohm, 1 ohm, zero point 0.5 V naught. Okay, I just opened this thing. Here I opened this current source, that is R equal to infinite ohm. Right? In this circuit, we are calculating this V1. I hope all people know that source transformation technique. Sorry, yeah, just a minute. This is 10 hours. Sorry. Yeah. We need to find out this source transformation technique. The source transformation technique is nothing but the voltage source in series with the resistance can be transferred to the current source in parallel with resistance, and vice versa. Both can be possible. The voltage source from voltage source to current source, and the current source to voltage, both can be possible. So let us suppose here the voltage is V and here the resistance is R. The current source is V by R amperes and the resistance remains same. Okay. Similarly for independent source as well. In our case, we have 0.5 V naught with having a resistance of 1 ohm, right? Which can be transferred to the resistance remains same, that is 1 ohm. The point here, we are transferring current source to voltage source. That is the value of V equal to I into R. Here I equal to 0.5 V naught and R equal to 1 ohm. Therefore the V remains 0.5 V naught. It is 0.5 V naught. Yeah. This I am redrawing. I am redrawing only this particular arm only. That is 0.5 V naught, 1 ohm. Now I am applying the KVL in this particular loop. Okay. Let us suppose this is having a current of I amperes. That minus 10 volts plus 2I minus 5 V naught plus 1I plus 4I equal to 0, right? And this V naught, that is V1 or V1, V naught equal to or V1, that equal to 4 into I. I'm just substituting this one to this, minus 10 plus 2I. Instead of 5 V naught, I'm just replacing V naught with 4I plus I plus 4I equal to 0. So we can simplify this thing. This is 2I minus 5 4 20I plus I plus 4I equal to 10. This is 2I plus 1I, 3I, 3I plus 4I. This is 7I, 7I minus 20I, that is minus 13I equal to 10, right? I equal to 10 by minus 13, that is 10 by equal to minus 0.769 volts. So V1, yeah, V1 equal to 4i, right? That is V1 equal to 4 into 0.769, that equal to V1 equal to 4 into 0.769, 3.076 volts. This is the voltage across this 4 ohm resistor. Yeah, this is the voltage across this 4 ohm resistor when the 10 volt source is acting alone. Okay, now we have to find out the voltage across this 4 ohm resistor when 2 ampere source acting alone. Yeah, when 2 ampere source acting. When 2 ampere source acting alone means we have to consider this thing and we have to make it as 0. We have to make voltage source 0 means we have to short circuit this 10 volt source. Okay, and the internal resistance of ideal voltage source is 0. So we have to just short circuit the voltage source. That is just we have to short circuit this terminals. Now we can apply source transformation technique. In this case, the source transformation technique is like this. The 2 amperes. This is like this, no? This part is like this, right? 2 ampere current source with 2 ohm resistor. We can transfer like voltage source in series with resistor. The resistance remains same, that is 2 ohm. However, the voltage equal to I into R, that I equal to 2 amperes and R equal to 2 ohm, that equal to 4 volts. We can replace with 4 volts. We can replace with 4 volts, 2 ohm, and previously we did source transformation technique for this thing. We are taking the same thing, so that remains same, that is zero point 0.5 V naught, 1 ohm, and 4 ohm. This is V naught. Again, we have to apply KCL in this particular loop. Yeah, KCL in this particular loop, consider this current as I naught. So this is minus, this is plus, right? Minus 4 plus 2 I naught minus 0.5. Okay, in the previous case we did, yeah, in the previous case it is Sorry for this inconvenience. In the previous case it is uh, 0.5 V naught, right? So here 0.5. So here it is not 20, it is 2. Okay, this 2i remains cancelled. This is I plus I, this is 5i. So I equal to 10i by 5, that is equal to 2 amps, and this voltage equal to 4 into 2, that equal to 8 volts. Sorry for the mistake. This, I hope now it is clear. Yeah, this is 0.5 V naught minus, so I naught plus 4 I naught equal to 0, right? Similarly, that V naught is same as previous one, only V naught equal to 4 I naught. The same equation remains, minus 4 plus 2 I naught minus 0.5 V. Instead of V naught I am substituting 4 I naught plus I naught plus 4 I naught equal to 0, that equal to minus 4 plus 2 I naught minus 0.5 into 4, that is 2 I naught plus I naught plus 4 I naught equal to 0. Thus 2 I naught cancel, and this 5 I naught equal to 4, and I naught equal to 4 by 5, that equal to 0.8 amperes, and this V2 equal to, that is 4 I naught, right? 4 I naught, that is 4 into 0.8, 3.2 volts. So from the superposition theorem, the total response, that equal to V naught equal to response corresponding to 10 volt source, and the response corresponding to 2 amperes, that equal to the response corresponding to 10 volt source, we already calculated, this is 8 volts, and the response corresponding to 2 ampere source, that is just we calculated, that is 3.2 volts. Therefore, the total response is 8 plus 3.2, that equal to 11.2 volts. Okay, the total response across any element when multiple sources acting is equal to individual responses at that element when all the sources are acting alone. That is the option B, it is 11.2 volts. Coming to the next problem, using the source transformation, the following circuit need to be reduced: a single voltage source in series with a single resistor. Determine the values of the final reduced voltage source and the resistor. We already seen that source transformation technique in the previous problem itself. First, we will transfer this voltage source in series with the resistance into current source in parallel with the resistance, that equal to We are just transferring the first one itself, 20 ohm plus 12 volts. We are just transferring to current source in parallel with the resistor. Okay, the resistance remains same, right? That is 20 ohm. The current source I equal to V by R. The V equal to 12 volts by resistance equal to 20 ohm. 12 by 20, that is 12 by 20, it is point, 0.6 amperes. Okay, similarly the second one we are transferring, that is okay, this is 16 volts in series with 40, 16 volts in series with 40 ohm. The 40 ohm remains same, and 16 volts, the I equal to 16 by 40, right? That is 16 by 40 equal to zero point 0.4 amps. Therefore, we can redraw this same circuit. Instead of second arm, I am just redrawing current source in parallel with the resistance, and instead of third arm, that is 40 ohm in series with the 16 volts, instead of that thing, I am just redrawing a current source in parallel with the resistance. The first one is directly the previous one, that is 3 amperes and 10 ohm. The second one is we just applied that source transformation technique here, that equal to 0.6 amperes in in parallel with 20 ohm, right? And the third arm just we did here, third arm, that is zero point 0.4 amperes parallel with 40 ohm. Here we can observe that the 10 ohm resistor, 20 ohm resistor and 40 ohm resistor are connected in parallel. So the R equivalent, that is 1 by R equivalent, we can write like this: 1 by 10 ohm plus 1 by 20 ohm plus 1 by 40. Okay, the LCM is 40, and here it is 4, here it is 2, here it is 1. So 4 plus 2 plus 1, it is, or one can directly calculate the equivalent resistance as well. That is 1 by 10. This value is, just I am directly writing this values, right? The 1 by 10 value is 0 0.1 plus 1 by 20 value is 0 0.05 plus 1 by 40 value is 25. Therefore, R equivalent equal to 1 by 0 0.1, 0 0.05 plus 0 0.025. Okay, that equal to R equivalent equal to 5.7142. This is equivalent resistance. That is, uh, and one more thing is, I'm just taking this circuit only. Yeah. Here, all the current sources are towards upwards, so that we can add all the current source like from just from KCL only. That is 3 amp plus 0.6 amp plus 0.4 amp equal to 4 amperes. Current source in parallel with the resistance, right? And in parallel with the resistance, that is 5.7142. This can be replaced with voltage source in parallel with the resistance. The resistance remains same, that is 5.7142 ohm, and the voltage equal to current into resistance, right? V into I, sorry, V into I into R is 5.7142. 4 into 5.7142, that equal to 22.8568 volts. The resistance equal to 5.1742 ohms, and the voltage source is 22.8568. Coming to that next question, determine the Thevenin's resistance and voltage for the following circuit. We have to find out the voltage across these terminals, that is A and B terminals, A, B. This is, yeah, uh, this is VTH, and we have to find out the resistance across these terminals. It is RTH, right? This is what Thevenin's resistance and Thevenin's voltage. So to identify the voltage, sorry, to identify the Thevenin's resistance, we have to replace all the current sources, all the independent sources to make zero. It means we have to replace this voltage source with short circuit and this current source with open circuit. So the circuit will becomes, this is our A point, okay. This is, let us suppose our we consider this is as a C point, and this is as a D point. This is our C point, and this is our B point, and this is our D point. From A to D, there is a resistance and independent voltage source. We have to replace this voltage source with internal resistance, that is 0 ohm. We have to short circuit this voltage source. Therefore, this 10 ohm, right? And similarly, here we have to make this current source to 0. That is, we have to open circuit this 5 ampere current source. Therefore, only 10 ohm. And here it is 20 ohm is connected in between C and B points, and one more 20 ohm is connected across I make it as a 0 as this voltage source, and 110 ohm is connected like this. Okay, this 20 ohm and 20 ohm and 20 ohm are connected in parallel. So the equivalent resistance is 20 into 20 by 20 plus 20, that equal to 10 ohm. So the same circuit can be redrawn as sorry, just a minute. Yeah, yeah, this is our circuit. The same circuit we just uh, we can replace this. I just replaced with the equivalent resistance. So this 10 ohm resistance, 10 ohm resistance, 10 ohm resistance are connected in star manner. So we need to convert star to delta. I'm just this is what the 10 ohm, 10 ohm, 10 ohm. I'm just converting the star to delta. This resistance equal to 10 ohm into 10 ohm plus 10 ohm into 10 ohm plus 10 ohm into 10 ohm by 10 ohm, right? It equal to 30 ohms. This resistance is also same as 30 ohm. This is also 30 ohm, right? So I'm just taking this circuit and just redrawing that new equivalent circuit. This all is going to be erased, right? Our new circuit will looks like this, and this point to this point, this is a 30 ohm, and this point to this point, this is a 30 ohm. This is 30 ohm, 30 ohm, and 30 ohm. Now this 30 ohm and 10 ohm are connected in parallel, and this 30 ohm and 10 ohm are connected in parallel. The equivalent is 30 into 10 by 30 plus 10, that equal to 7 point, that equal to 7.5 ohm. Similarly, this is also 7.5 ohm. Therefore, a new resistance, that is A cross D equal to 30 ohm. The 7.5 and 7.5 are connected in series, so the equivalent resistance will be just adding these things, that is 15 ohm, that equal to 15 ohm. So RTH equal to 15 ohm is parallel with the 30 ohm, that equal to 30 into 15 by 30 plus 15, right? that equal to 30 into 15 by 30 plus 15 that equal to 10 ohm. Therefore, the RTH equal to 10 ohms. Okay. Now we have to find out VTH. The VTH equal to the voltage across this A and B terminals, that equal to, just consider this is as a VA and this is as a VB. Okay, just we are applying this source transformation technique across this one first. That equal to 5 ohm parallel with 10 ohm resistor, 5 ohm parallel with, sorry, 5 amperes parallel with 10 ohm resistor. This can be written as, the 10 ohm remains same, then V equal to I into R, that equal to 5 into 10, that equal to 50 ohm, sorry, 50 volts. So this arm can be replaced with this one, right? That is 10 ohm resistance in series with 50 volts. And similarly, this I am going to transfer the 20 volts in series with, yeah, that is, looks like this, right? 20 volts, sorry, 20 ohm in series with 20 volts. This can be represented with the 20 ohm remains same, and the positive potential is downward, so I equal to V by R, that V equal to 20 by R equal to resistance 20, that is 1 amperes, right? Yeah, I'm just redrawing the previous circuit, that is VA 10 ohm, 10 ohm, 30 volts, 10 ohm, 50 volts. Previously we replaced with 20 ohm and 1 amp, right? This 20 ohm and this 20 ohm are connected in parallel, so that equivalent resistance will be 10 ohm with 1 amp. Again, I am doing the source transformation, that is 10 ohm remains 10 ohm, and that 1 amp becomes 1 amp into 10 is 10 volts, right? 10 ohm, 10 volts, 10 ohm. This is VB. Okay, this is our final circuit. I am just applying a nodal analysis at this point. I consider this as a Vx. That Vx minus 30 volts by 10 plus 10, that is 20, plus Vx minus 50 by 10 plus Vx plus 10 by 10 plus 10. This is 20 equal to 0. The LCM is 20. That is equal to Vx minus 30 plus 2Vx minus 100 plus Vx plus 10 equal to 0. Okay, this 20 will goes to that side. That will, so the new equation will be 20 will goes to that side. So this, yeah, v Vx 2Vx, that is 3Vx, 3Vx plus Vx 4Vx minus 30 minus 100, that is minus 130 plus 10, that is equal to minus 120. It goes to that side of this plus 120. So Vx equal to 30 volts. So in this circuit, the Vx at this point is 30 volts. So this current, let us suppose I consider this current as I1. My I1 equal to this voltage is 30 volts and this voltage is 30 volts. There is no potential difference across uh, this 10 ohms. Sorry, yeah. This voltage is 30 volts and this voltage is 30 volts. There is no potential difference across these 20 ohm resistance. So the current is 0. Is it clear? And this voltage is now consider this current as I2. So the current is 0 means the VA equal to 30 volts, right? And consider this current as I2. My I2 equal to my I2 is the flowing towards this direction. That I2 equal to Vx. This is my I2, right? Vx plus 10 by 20. That my Vx is 30 plus 10 by 20. That equal to 40 by 20. 2 amperes. My I2 equal to 2 amperes. So the potential across this 10 ohm resistor is 2 amperes into 10, 20, it is 20 volts, right? So my VTH equal to just yeah, just a minute, I will erase these things which are not needed. My VTH is voltage across these points, right? So just I am applying this current is 0. So my VTH is same as the voltage across this one. This voltage is plus 20 volts. This voltage is 10 volts. So my VTH equal to 20 volts minus 10 volts, that equal to 10 volts. So VTH equal to 10 volts and RTH equal to, we already calculated that RTH equal to 10 ohm. Okay, I'm moving to the next question. Next question, determine the Thevenin's resistance and voltage for the following circuit. Okay, first we will do the when the circuit consisting of a dependent sources like a dependent current source or dependent voltage source. To find out the Thevenin's resistance, we can do two methods like you can find out the VTH and you can find out the ISC, and from these two values you can find out the RTH, that is VTH by ISC. This is one method of finding the RT equivalent resistance. And one more method, you can energize the same circuit. Like I'm doing the second method. We have to uh, make zero this independent current source. That is, we have to open circuit, right? I'm just open circuit the 2 amperes source. So this I naught still exists, I naught, and this is 10 I naught, and this is 2 ohms. This is 4 ohms. This circuit is not having uh, any active source, so we have to energize this thing. Let us suppose with 1 ampere. I'm energizing this as a 1 ampere current source. My aim is to find out the equivalent resistance seen from these two terminals. I want to find out the resistance seen from these two terminals, that is RTH, right? I'm applying 1 ampere current source. So I will found out this voltage across my current source. So from Ohm's law I can find out this V by I. Here my I equal to 1 ohm. So if I find my voltage is directly the Thevenin's resistance, right? For that thing I'm just applying 1 ampere voltage, 1 ampere current. Okay, I'm just applying 1 ampere current. My 1 ampere current is in this direction, which is same as this I naught. So I naught equal to 1 amperes. Now apply that KVL in this circuit. Just consider this is as a V only. Minus V plus 2 into, in this circuit 1 ampere current is flowing. Why? Because these all elements are in series. So 2 into 1 ampere minus 10 I naught. Here I naught equal to 1 ampere. So 10 into 1 plus, like this, right? Plus 4 into 1 ampere, right? It equal to 0. That is, or V equal to, just I send this V to that side. That's it. V equal to 2 minus 10 plus 4. That equal to 4 plus 2, this is 6. 6 minus 10, this is minus 4. So R equal to P by I, that equal to minus 4 by 1, that equal to minus 4 ohm. This is the Thevenin's resistance of the given circuit. Whereas we have to find out the voltage also. Now we have to find out voltage across this element. So the 2 ampere source This current is 2 amp, right? Why? Because this is open circuit, the current flowing through this one is 0, right? Now I naught equal to 2 amperes. Now apply this KVL in this thing. Okay, VTH equal to the current through this 2 ohms is 0. So the voltage drop across this 2 ohm resistor is 0 volts, and this minus 10 I naught, that equal to minus 10 into 2 amperes, that I naught equal to 2 amperes, and plus 4 I naught, that I naught is 2 amps, minus 20 plus 4 into 2 is 8, is equal to minus 12 volts. That is the VTH equal to minus 12 volts, and RTH is equal to minus 4 ohms. Okay, that equal to minus 4 ohm and minus 12 volts. This is option D. And the last one, determine the Thevenin's resistance for the following circuit. Okay, here this circuit, which is consisting of a dependent voltage source. However, there is no independent source in this network. So we have to energize this circuit, and we have to find out the what is the equivalent resistance. Okay, if time permits, I will do in two methods. In this method, we can do with two methods. So we can apply 1 volt, we can energize with 1 volt source, or we can energize with 1 ampere source. Okay, you have to choose whichever is easiest and whichever is short form. So first I'm choosing 1 volt source. However, both the answers remain same. If time permits, I will do both the methods. First, yeah, I am energizing with 1 volt source. So I am energizing with 1 volt source means I applied 1 volt source. I will find out the current through this thing. From the Ohm's law, R equal to V by I. So my V equal to 1. So so that my resistance is just inverse to the this current, the current delivered by this 1 volt source. Okay, this is 4 ohm, this is 1 ohm, this is 2 ohm, this is Ix. Sorry, this is, they represented in the short form, sorry, small letters, Ix. Yeah, and this is 10Ix. Here there are two loops and one node. Which one is better? It is better to apply nodal analysis. VA. This current is, let us suppose, I1. This current is, let us suppose, I2. So the nodal analysis at node A point is at node A equal to Ix plus I1 plus I2 equal to 0, right? This is just KCL only. That I1 equal to Vx minus 10 Ix by 4 and that Ix equal to Vx by 2, then this I2 equal to Vx minus 1 volt by 1, right? I think this is clear. I'm just copying these three. Yeah. So we have to from the what is the KCL equation, that is this one, the total all currents is should be 0. So Vx minus, instead of Ix I am substituting this Vx by 2. Okay, 10 into Vx by 2, sorry, so yeah, this by 4, right? Just instead of Ix I substituted this one Vx by 2 plus Vx by 2 plus Vx minus 1 by 1, that equal to 0, right? This 2 1s are 2 5s are, that is Vx minus 5Vx. Vx minus 5Vx is minus 4Vx by 4 plus Vx by 2 plus Vx minus 1 by 1 equal to 0. So the LCM is 2, right? It is minus 2Vx plus Vx plus 2Vx minus 2 equal to 0. Minus 2Vx minus 2Vx. If you send 2 to that side, then Vx equal to 2 volts. So our Vx equal to, Vx is here only, no? Vx equal to 2 volts. What about our I? I is just opposite to this I2. I2 equal to Vx minus 1 by 1. So our, yeah, our I equal to just opposite to I2, that is minus I2, that equal to minus of Vx, that equal to 2 minus 1 by 1. Okay, that is 2 minus 1 by 1. What is this value? 2 minus 1 means 1, 1 by 1 minus 1, that is minus 1. So previously we defined our R equal to V by I, or V equal to 1 ohm, our V equal to 1 volt, our I equal to minus 1 amp. So our resistance is 1 by minus 1, that equal to minus 1 ohm, right? So the Thevenin's resistance is minus 1 ohm. Okay, the same problem we are doing with energizing 1 amp current source. Okay, just we applied 1 amp current source. Okay, now also we interested to find out node voltage. Okay, this is not at all related to previous notations here. Okay, we represent with some V naught to avoid the confusion. And this current we will represent with some IA. This is, anyways, this current is flows through the side, therefore this is 1 ampere. From the nodal analysis, that is from the KCL at V naught, 1 ampere equal to Ix plus Ia. Okay, this Ix equal, sorry, Ia equal to 1 minus Ix. We can write like this. Okay, V naught, just we are applying that nodal analysis at V naught, 10, same as previous one, 10 Ix by 4 ohm, and this Ix equal to, this Ix equal to V naught by 2 ohm equal to 1, right? So this Ix you can substitute, this Ix is same as the previous one, that is V naught by 2. 1s are 5s are, that is V naught minus 5 V naught, that is equal to minus 4 V naught by 4 plus V naught by 2 equal to 1. 4 minus 1, so minus V naught plus 0.5 V naught equal to 1. 0.5 minus 0.5 V naught equal to V naught equal to 2 volts, right? Sorry, minus 2 volts. Okay, in this case the V naught equal to minus 2 volts, but we want this voltage across this current source. Let us suppose this as a VA. Okay, that we want this VA. That VA we can write like this, right? VA, just we want this one, so we can subtract the drop across this 1 ohm from this V naught. So VA equal to, this is plus minus, why? Because our 1 ohm source is this, so equal to V naught minus 1 into, the current is flowing towards this direction, so that is 1. Therefore VA equal to V naught plus 1. The V naught is minus 2 volts plus 1, that is equal to minus 1. So previously we already discussed that yeah, our R equal to VA by I. Our I equal to 1 here, so it is directly V, that V equal to minus 1. So that RTH equal to minus 1. In the previous case also it is remains same, that is minus 1 ohm. In the present case also minus 1 ohm. Therefore, whatever the method may be, the answer remains same. So we have to decide the method based on the complexity of the circuit. I hope this one is clear. This all the lectures are available in this basic electrical circuits YouTube channel. The YouTube channel link is here. Thank you. If you have any doubts, you can drop it in a comment box. If no one is having okay, fine. We can close this session.